Okay, so in the last class, what we were talking about is we were talking about how do you do update on the table, right? We have seen how do you do simple update. We talked whenever you update, you always make sure you have correct where condition. If you don't put the correct where condition, or if you don't add the where condition, it's gonna update the whole table, right? So how do you make sure that you are updating the correct record? First, write a select. Make sure you're getting the record that is the one that you want to update, and then you write that query as an update, right? So you say, okay, I want to update the table name and set the flag on the table equals to 1 where contact ID equals to 1036, right? So let's say if I say human resources dot employee, right? And if I look in contact ID 1036, what do I want to do is for this contact, I want to update the salaried flag from 0 to 1. How do I do that? I say update table name set salaried flag. The set means the column that you want to set to whatever value. So I want to set this column equals to 1. Okay. Now if you run just this thing, it's going to update the whole table. What you want is you want to update for only contact ID 1036. So you put that in the where condition. Okay, and then you run this, it will update only one record in the table. Okay, so if I execute, oops, wrong table name. If I update table name and then execute it, see it says one row is affected. So if we take a look now, the current flag is 1. Sorry, the salaried flag is 1, right? The salaried flag is 1. So I update it back to 0. What it is actually. Okay, so that's how you're gonna make an update to the table. But when you're doing an update, make sure you create your own table, you create your own data, and then do the update. Don't try to mess around with the employee table because you will be using it at least for now, until you finish the practice and everything, or the assignments. Okay, so we have seen this in the last class. We have seen if you have to update the multiple column, all you can do is put the comma and the column name. So let's say you want to do current flag equals to 0 as well, you can update that. Okay, so you just put comma and keep updating the column. Hold on. All right, so then if you have more than one column, all you do is you put the comma and you keep you can update all the columns you want. So what you can do is any of the columns that you have in here you want to update, you just put the comma and keep updating all the columns. Okay, all right. Now let's say you want to update. So right now, which table you are updating right now? You are updating the human resources.employee, right? What do you want to do instead is so let's say if they give you the email ID for the person and they want to update the record in human resources.employee, would you be able to update the record of the employee based on his email address or based on his name? Can you do that in this table? Do you have email address or name in here? So let's say if I told you for Tim Buck, I want to update his salaried flag from 0 to 1. Would you be able to do it? For a person Tim Buck, or his email address is timbuck@adventureworks.com. You know the email address, you know the name. Would you be able to update the record for that guy? No. Why? Because you don't have the name in here, neither you have the email address, right? So how do you update how do you update the table if you don't have the information in here? What do you need to do? Anyone? What do you need to do if you want? Hey Dan. So what you're trying to do is you're trying to update the human resources.employee table. Okay, what you're trying to do, you're trying to update human resources.employee table, and you're trying to update the human resources.employee table based on a person name or his email address. Do you have person's name or email address in human resources.employee table? You don't have, right? So what would you do now? If you want to update Tim person, if you know the name of the person and you know his email address and you want to update the salaried flag in here, okay, or the current flag, either of them. You want to update this value. You don't know which record you will be updating because there are about 290 records in the table, and you don't know who is Tim Buck or who is person X, right? You know his email address, you know his name. What would you do? Anyone? How would you find out the name of the person or the email address of the person from this table? No? Everyone, do you remember joins? If I ask you, can you give me the name of this employee? Can you give me the name of the employee? And what would you do? You forgot select, how to do select. Person.contact, right? Thank you. So what you're going to use? You're going to use the, so if I go to person.contact, what I'm going to use? Do I have the employee ID in here? I don't have. Contact ID, yes. Good. So what you're going to do? How you going to find out the contact ID for that person? By a name? So you're doing it correct. You said you have to do person.contact, and you have the name in here, and you have the email address. So what you're going to do is, you can find the contact ID for that person from here and look up that contact ID in this table, right? Right, Wilson? Okay. So what would be the other way of doing it? You do a subquery. What would be the other way? Can you do like this? And you say where email address equals to this. You put in the where condition, email address equals to whatever email address you have. Or you can say where first name equals to or last name equals to, right? You can search by first name and last name. So all you're doing is you're joining these two tables together in your select in order to get oops, I'm in the wrong database, I guess. All right. So now what you do is you do select star from adventureworks.person.contact, join an employee on the contact ID, right? So you're getting all of them. Do you need all of them? No, you need only one where you know the name or you know the email address. So you can do a where condition and you can look for particular email address that you're looking to update, right? Now you know that person's contact ID is 1246, right? Person's ID is 1246. So now you don't want to do something like this, what you did in here. You don't want to do like this. You don't have to do is update employee where contact ID is equals to 1246. You don't need to do that, right? What you can do is, because you have joined, you find out the particular record. All you need to do is you need to convert this query. You don't need to get the contact ID and write a query like this. No, because with the update, what you can do is instead of writing a separate query, we need to convert this into the update. So all I'm going to do is, what do you want to update in here in this table? When you're getting this record, what do you want to update? For this person, you want to update his salaried flag and current flag, right? In which table it exists? These two columns in employee table, right? So you're gonna say in from condition. So what you're gonna do is you're gonna take this query what you have, okay, and you're gonna remove select star. You remove that, and here you start writing update instead of select star. You write update. Which table do you want to update out of these two? Do you want to update person.contact or do you want to update employee table? Employee table you want to update, right? So you say update E which is employee table, right? And then you say set. Okay, you say set. What do you want to set? You want to say set salary flag is equals to 0, and you put the comma, and other column you want to update is the current flag equals to 1. So now, even though you're looking up this, you're updating the employee table, right? But you're looking up on contact table. So you do a contact search on contact table, you do a join, and then you update the employee table. So all you're doing is, based on one table, you're updating the other table, right? So all you do is, if you know how to write the select, you get the record, and then you convert this select star into update and set. That's it. So if you know how to do your select, all you do is update table name, which is E, and then you set this thing, whatever columns you're trying to update. Right? Okay. So in this way, if you have multiple columns, you can update multiple columns. Okay. Keep just adding comma and updating it. Okay. So now the other way you can do it is, think about, you are keep changing the email address, okay, in here. So what you can do is, if you keep changing the email address, and what do I want to do is, I want to pass this as a variable to the query. What is the variable? When I say about variable, it means a variable is a variable is a variable can store the data in it. Okay, so when you say a variable, what it can do, it can store a data in it. So what you can do is, instead of directly giving the name or the email address in the where condition, you can put the variable in here. And when you put the variable value can change every time. So what I did is, I replaced the email address with variable. So I'm saying is, always whenever you're trying to update the record, find the variable value and update for that variable value. Okay, now how do you initiate the variable? So if you have, it's a variable that can hold the data for you, how do you declare the variable? So when you're saying, okay, I want to use a variable, you have to let SQL Server know, okay, I want to declare a variable. It means you want to say, I will be using this variable in my script. Okay, so you first declare the variable, and then you set the value of the variable. Okay, so what I'm going to do is, how do you declare the variable in SQL? You say declare, and you can have any name for the variable. You can have email address, or you can just have email, whatever you want to give, but it has to start with @. Okay, so it starts with @, and then you can give any name you want to give to your variable. Okay, any name you want. So you say, okay, I will define a variable which starts always, the variable always starts with @. Okay, @. It has to always start with @. And then you can have the name of the variable you want. And then you define the data type. What is the data type? What are you trying to store in that variable? Are you trying to store integer? Are you trying to store a float? Or are you trying to store date and time? Or are you trying to store a string? So because I'm trying, my email address is a string, I say it's a maximum character I want to store is 100 in this variable. So I say character 100, declare variable name and the data type. And then you say, I want to set the email address to this one. Okay, so now when you're going to run your update statement, it's going to look for email address, which is nothing but what you stored in this variable, right? So anytime now, if you have to change the email address, you change it in here, it will automatically read the variable from here, whatever you mention. So if you're updating one by after the other, you just need to change in here. You don't need to change the query, right? So your query is always same. All you're doing is you're changing the variable value. Okay, so if you have multiple employee that you want to change from salaried flag to 1, whatever it is, from you want to change it to 1, then all you do is you keep changing the email IDs for those employees, and you keep running, run this query. So you have to run the whole thing together. Okay, if you just run this, the second part, it's not going to work, because when you're running the query, even though you defined and you set the value, but when you're running, you're only running this part. So it doesn't know where this email address comes from. So every time you run your query, it has to be all together. So it knows first you declare the variable and you set the value. So the declares are just a placeholder, okay, in which you can hold the values. All right, it doesn't get saved in the database. So that's why if you're just trying to run this, it's going to give me an error, must declare a variable email address, because I was just selecting this and I haven't declared in the select statement. I mean, the select statement means the statement that I selected. Okay, so you include whole thing, and then if I run this query now, it's going to update the salaried flag to 1 for that employee. Okay, so if I execute the query, it will update one row. Okay, so if I have another email address now, all I need to do is change this email address, run the query. If I have another, change the email address in here and run the query. We're gonna see how the variables will be useful when we're gonna learn the stored procedures and everything, but keep in mind the variable concept as well. Okay, all right, so now if you update it by mistake, you know you're gonna update the whole table and you won't be able to recover what you did wrong. Okay, all right, so now let's say by mistake you updated all the employees. Now let's say, what did you do? You have a backup for an employee table? Let's say by chance when you're doing the update, you took the employee backup of the employee table. Okay, so I'm assuming that I have a backup of my table in my database. Okay, I am assuming that. Now when you update this whole thing, oops, what happened? I updated everything to 0, both of them, right? All of the records in table 290 records are updated to 0. So let's take a look what does table looks like now. So if I do select star from employee, okay, if I do this, what I'm gonna get, all my salaried flag and all my, oops, let's see what's going on. So I update my table. Oh, sorry, I was updating the sick leave hours and the current flag, and I was looking at the salaried flag column and I was like, why there is a 1 in there? My bad. Okay, so if you look at the column sick leave hour and current flag, what did we set to? We set everything to 0, right? So this is happened by the mistake. Now what would you do if you have a backup table? So you have a backup table which is called human resources.employee, right? You have the correct value in there. Now what do you want to do is, you want, so if you look at human resources.employee, you're gonna see the sick leave hours and current flag are not all 0. They have the 1 as well. So if you leave it, so see in here current flag is 1, sick leave hours is, each has a different number. Now what would you do where you updated the wrong? So in the employee table you updated it to wrong, right? You updated everything to 0. How would you recover the values for the sick leave hours and the current flag? How would you do it? So that where you screwed up in the table, if you have a backup table, how would you recover sick leave hours and current flag for all the employees in employee table? Your backup table is this one, human resources.employee. What would you do? Anyone? If you know the select, it's easy. Tell me, what would you do? So in here, I have everything 0. But in table, this is my backup. What would I do in between these two tables? Are these exactly the same table? Except these two columns, the table is exactly same because it's all the employee table and this is the copy. So the employee table in here it's only lost, it has lost the value for these two columns. Do you know in between these two tables what is the Can you join these two tables together? How is how are the how does the records exist in this table? What do you know? It's a primary key in here which identifies each record uniquely. You know the employee ID is the key to both of the table, right? Employee ID is key to the table. So each record is uniquely identified by employee ID. So if each record is identified uniquely by employee ID in the table, all you can do is look the employee ID 1 in here, what its value. Okay, so if you look in here for employee ID, what is the value for 1? 30 and 1. All you need to do is for employee ID 1, you need to update 30 and 1 in here and keep doing it for all the 290 records. Just look from here, update it in here. Would that be a good idea? So you need to do is where employee ID equals to 1, where employee ID is equals to 1, right? And what was the value? Sick leave hours was 30 and salary flag equals to 1. You update 1 and then you look at the employee ID 2 then. What's the employee ID 2 value? 41 and 1. So you're going to say 41 and 1 employee ID 2 and you update the record. Would you be doing that? So you update one record. Then you look at the employee ID 3. What's the value for employee ID 3? 21 and 1. So I say 21 and 1, and which is this value for? Employee ID 3. So I'm looking in my backup table and updating in the employee table. Is there a simpler way to do it? Whether you don't want to, if you have a million records in the table, you don't want to keep doing this for like days and days. How would you do that? No? Join, right? You can join these two tables on employee ID because that's the unique key. So what you're going to do is you're going to say, okay, this is my backup table. I'm going to say human resources.employee as E join with the employee table, which is E1. I say it as E1. On which column you're going to join? You're going to join an employee ID because when you are doing these two tables back and forth, you are looking the employee ID in here and you are updating the employee ID. You are looking, so basically you're doing a join between these two tables on employee ID, right? So you do a join between the two table by employee ID. It means you are getting each employee ID, what is their sick leave hours, what's their current flag, right? So if I run this query, see, I'm getting those two records that I updated, but everything else is 0 in here, right? So I updated the two records which are correct, but I haven't updated everything. So how can you update it now? So you see for employee ID 1, 30 and 1. So I have to update 30 and 1 in here. 80 and 1, I have to update 80 and 1 in here. 62 and 1, 62 and 1 should go in here. So for employee ID, you are updating in this table, which is employee table, right? So you selected E.employee ID, E.sick leave hours, and E.current flag, which is your backup table. And this E1 is the table which you screwed up, right? When you run the update by mistake. So what you need to do now, you know, okay, do you want to update everything in the table? Yes, you want to update each of the column from the corresponding column. So sick leave hours should come from here. Current flag should come from here. Sick leave hour for this should come from here, right? So if all you need to do is you take these two columns, put it in here. Take these two columns, put it in here. Take these two columns, put it in here, right? You need to keep doing that. Take this one in here, put it here. Take this one, put it here, right? So now how would you do this? If you have the select statement, all you need to do is you need to convert this select into update statement. So all I need to do is I write this as an update, okay? What table I am updating? Can anyone tell me what table I am updating? E1, right? Which is employee table was messed up. And I say set. What do you want to set? You want to set E1, right? E1 dot current flag which you messed up. So you want to set this. This value will come from where? E dot current flag. So you're gonna say E1 dot current flag equals to E dot current flag, right? So you want to set this column from here. So that's what I'm saying. I'm saying E dot current flag should be replaced by the value I have in here. and I'm going to do the same thing for e1.sickleave hours should come from, where does it come from? Where it should come from? So e1.sickleave hours should come from e.sickleave hours, right? So I'm saying that, okay, replace e.sickleave hours with e.sickleave hours. Okay. So now you set sickleave hours from your backup table. E is your backup table, right? So you're putting the backup table values into your table which is messed up. And the same thing, you're taking the value from the backup from the current flag and putting into your table which is messed up. Now if you run the update statement, all it's going to do is it's going to update all the 290 rows, and if I run this query now, see, all of my records got updated. So I don't have any the things that I messed up in here, I fixed it, right? Or no? Okay, any question? So now what I'm trying to tell you is, if you know how, if you first make this, whenever you have to do the update, first make a select statement. Okay, once you make a select statement, you would be able to convert that into the update and the set, right? So whenever you are updating the table, you're going to say update table name and set the columns that you are trying to update in the table. So if I look in the employee table, which columns did I messed up? I messed up these two columns, sickleave hours and current flag. So I'm setting up, which is my employee table in here is E1. So I'm saying update table E1 and set E1.sickleave hour from my backup table, which is e.sickleave hour, right? E.sickleave hour. And I put the comma and I say, okay, one more column I want to update, E1.current flag, and I'm going to say which is going to come from e.current flag, right? Which is coming from e.current flag, which is your backup table, right? So there are the same table, one is backup and one is your table which is messed up. So you're saying, okay, I know in this table each column is recognized uniquely by employee ID. So you join on the employee ID and then you update the record from the corresponding column, right? Okay. So this is like the complex statement you can think about that you have to update based on the join. So always look for first select, write a select and make sure you're getting the select statement. Once you get the select statement, all you do is write an update and set, and everything is same from the from condition. So you change the select to update and set. Okay. Yes. Mm-hmm. Yes. Yes. Uh-huh. Like this? You mean like this? Mm-hmm. Yes. 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 So you can switch around the column, it doesn't matter, but you need to make sure which one you are updating. are you trying to update the E1 or are you trying to update the E? That's what you need to make sure. The first column you write in, it should be the column that you want to update, and the second is the one from where you are updating. So this is the column will be getting updated from this column. Okay, if you do switch this one around, then the E table will be updated from the E1. So you're gonna do is you're gonna overwrite your backup table with the table you messed up. So even if you do this, if you flip this column around, what you're gonna do is you're gonna screw up your backup as well. So if you update from your messed up table to your E table, which was your backup, you screwed both of the table. So you have to make sure you update it in the correct direction. So this is the column you want to update from this column. So first the first one is you're trying to update, and the second one is from where you're trying to update. Yes. And it doesn't matter if you put this one, if this thing is before and this thing is after. It doesn't matter. The order doesn't matter for the columns. Okay, you can have it either way. Yes. 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 Yep. The idea behind is simple. You look in the employee table. Okay. Let's see. Let me make sure this. Let me screw this up again. So I messed up again the table employee. Okay. What's in here? Sick leave R and current flag is 0. If you have a backup table, what you're going to do to find out the actual value of sick leave hours and current flag for this employee? What would you do? How would you find out? So in this table, you have the 0, 0. What do you do? Backup in the same field and for the same employee, right? Not just the same field, same employee and the same fields. So if I go in the backup table and I look, okay, where employee ID 1, what's the value? 30 and 1. So how do you looking up? What did you use to do a lookup? Did you use the employee ID, which was the key that identifies each record uniquely in the table? So if you're using the key as an employee ID to look in the table from here to here, that's what I'm doing. The same thing with the join. Okay. So if I ask you, okay, can you give me for employee ID 2, what's his actual value before you did messed up? What you're gonna do? You're gonna go in this table. Where you're gonna look this time? Do you gonna look in this first row? No. This time you're gonna look in the second row because you're looking for employee ID 2. So basically you're matching employee ID from here to here, from here to here, right? From one table to other table on employee ID. So that's what I'm doing. I'm matching from employee to this using this ID. So I'm saying, okay, give me all those where employee IDs are same, and give me these columns only. I don't need everything else. I just need to see the columns those are messed up. So it shows me for the employee ID. Is that the correct? 30 and 1 for the employee ID 1, for 2, 40 and 1, for 3, 20 and 1. So all you're gonna do is you're gonna say, put this sick leave hours what I have in here to this column, right? So that's what you did. Where? In here. That's what you did. And you say, okay, update the current flag, whatever I have in here. So that's what you did. Update the current flag from the messed up table to the from your backup table. Okay. All right. So I think that's what that's usually what you're going to do is make sure you write the select statement first and change that to update and set. That would be the easiest way of writing an update. So you know basically what you update. That's what I always do. I first write a select, so I know these are the values that I'm going to update. Okay. All right. So now let's see. Moving on to the next topic. What do we want to do is we talked about these tables, right? The temporary table, the local table, and the global table, right? Yes, in the last class we talked about the temporary tables. So see, I think. Okay. Okay, so before even going into the other things, what I want to do is first, I want to, so what did we see till now? Till now we have seen, did we see select? So what are the three statements we started with in the SQL? What were those three statements? Anyone remember it? DDL, DML, and DCL, right? These were the three statements: data definition language, data manipulation language, and data control language, right? These were the three. So anyone remembers what were in the DDL? What were the DDLs and what is the DML? Create, alter, and drop. Yes. Right. And what is the DML? Delete. Okay. Right. Okay. Did we miss any of these from here? We covered create, we seen alter, right? We seen drop, we seen select, we seen delete, and we have seen update, and we have seen insert, right? So the next thing that we're gonna start is, so these with this commands, what you were doing, you were creating the table, you were dropping the table, right? So create the table, select the data from the table, delete the data from the table, update the data and on the table, insert the data, and drop the table, right? So all these commands are used for changing one of the object in SQL, which is table. So the table is the object in the SQL server, right? So in the SQL or SQL database, table is one of the object, and you are using on that object all these commands, right? You are using how to drop the table, how to create the table, how to select the data from the table, all you were using on the table. Now we're gonna almost done with everything about the table. Now we're gonna start different kinds of objects in the SQL server. So this is just one of the object type that we have learned how to use it. This is one of the biggest portion. The table is one of the biggest portion. Once you understand the table and the scope of the table, how you use the table with all these statements, you have gained a lot of knowledge about SQL, because that's the main thing. That's where your data is stored. Now there are other things like indexes, stored procedures, functions. Okay, that's what we're gonna talk about next. And these are very short topics, okay, in the SQL. But these are the different kind of objects that you have in the SQL is index, stored procedures, functions, tables, triggers. Okay, we're gonna talk about those in now. Okay, so we are done with the table. Now these are the objects that doesn't store the data. If it doesn't store the data, can you apply any of these statements? No, because these stored procedures index, they doesn't store the data. All you can do is these objects are used on the table. So let's say if you're using a stored procedure, you write a stored procedure on the table. If you write an index, you write an index on the table. So these are the objects that are used to help the table or to get the data out of the table. Okay, so all these are nothing but an object that are like appendix to the table that you can use to help get the data faster or to get the data from the table. Okay, all right, functions, stored procedures, and indexes. So if this doesn't store the data, you cannot use any of these commands. So only on the tables these four works. Okay, but any other object like index, stored procedure, functions, you use this command. So you create a stored procedure, you alter stored procedure, and you drop a stored procedure. Okay, same thing, you can create an index, you can alter an index, you can drop an index. Function, same thing, you can do just these three things. You cannot do any of these three things with the indexes. Why? Because they simply doesn't store the data in the SQL server. They just help the table doing certain things in the database. Okay, all right. Any question about objects in the SQL Server? Is it a little bit clear? What is table, index, stored procedures? These are the objects in the SQL Server, and these are the commands that you use for these objects. And only table have a only table can use these commands because it stores the data. Any of these, they doesn't store the data, right? So you cannot use the data manipulation language on that. In SQL Server, if someone asks you, okay, in SQL Server there are 10 different types of objects where you can store the data. Only in the table you can store the data, nowhere else. Okay. All right. So let's start with indexes. What are the indexes used for? What does the index do in SQL Server? Why do you need an index? Okay. Very simple example I will give you. If I give you a book without an index, and if I ask you, can you give me chapter 23 from the book? How would you find out chapter 23? What would you do? If I give you a book with no index on it, and I give you the book and you have to find chapter number 23, what would you do? Anyone? That's what I'm saying. There is no index, there is no table of contents, there is no glossary, nothing. It's just the chapter starts with, the first page of the book is chapter 1. Then you find it. Just keep going from one page to the last page until you find page number chapter 23, right? Because you have no idea where does chapter 1 ends, chapter 2 ends, chapter 3 ends, or chapter 22 ends, right? Do you have any clue? You don't have any clue. If I give you a book, you don't know. All you're gonna do is either you're just gonna like zip through the book and keep finding chapter 22. I mean, you're gonna find, like, you're gonna do the math. Okay, I see the chapter 18. I just need to go to the later portion of the book. Oh, I found chapter 25, so it should be in between this bundle, right? Does it make sense what I'm saying? So you're gonna zip through, or you're just gonna keep going through pages one by one until you find the chapter 23. Is that a correct solution to find the chapter? I mean, is that an efficient way? Not correct. That's a correct, but is it efficient? It's efficient? No, because it's taking a lot of your time to find chapter 23. What would be the easier way of doing it? Like you said, if you had a table of content, or if you have a glossary, or if you have an index at the front. Index or table of content is the same thing. It will help you what you're looking for. So now if I give you index, or if I give you table of content, and if I say, can you give me chapter 23, what you're gonna do? You look in the table of content, you look, chapter number 23 is on page this, you have the page number, you go right directly to that page, right? You still have to find a little bit, but it would be easier this time, because you know, okay, you open the book, you are on, let's say, page number 23 is your chapter 23, so you know it. If you open the book and you go page number 18, you know it's going to come after. So this time it's become easier to find, right? So the same thing in the database. When you have data in the table and you say, okay, can give me the employee ID 21. Okay, look at this table. If I ask you, give me the employee ID 21, what you're going to do? You're going to go one by one all the way. So the SQL Server, what it's going to do? It's going to go just one by one all the way down until it finds the 21. In which case, what would be the case when SQL Server has to go through all the records to find 21? When it doesn't has an index. But if you put an index on the employee ID column, what SQL Server will get help with? It knows on which pages in the disk this information is stored. So what does the indexes do in the SQL Server? Anyone? What does SQL indexes do in the SQL Server? It makes your query run faster. So I'm saying, so the same thing is the indexes in the SQL Server as well. It helps you to find the data. So if you have the indexes in the SQL Server, what it will help you? When you run a query, you get your data faster. You get your data efficiently, right? You will be using your resources. So let's say if you have 1 million rows in employee table, and you have to find the employee ID 50,000. If you don't have index on the table, what SQL Server will do? It has to go each record until it finds 50,000, right? If there is no index. Does it make sense? But if you have an index on the table, what it's going to do is it's going to say employee ID 1 to 100 are on page 1, employee ID 100 to 200 is on page 2, employee ID 200 to 300 is on page 3, employee ID 900 to 1000 is on page 9, employee ID 2000 to 2001 is on page number 21, whatever, right? So if you know that, then if you're looking for employee ID 50,000, where are you going to go? You're going to go on page number 500, right? And you will find that employee record. So if there are indexes, what it's going to help? The indexes will help to run query faster. So it doesn't have to go all 50,000 rows. It just goes to page number 500. And in that page, it's going to look where is my employee ID 50,000, right? So the indexes helps to improve the performance of the query, the runtime of the query. Okay, so same thing. What you do is, if I give you the book, you're going to take a lot more time if you don't have the table of content. The same thing with the SQL Server. Okay, now if you understood what the indexes is, what's the concept of index, let's look the detail about indexes. What are the different kind of indexes in the SQL Server, and how does it help? How do you create the indexes? What are the advantages and disadvantages of this indexes? Okay. So there are two types of indexes in the SQL Server: clustered index and the non-clustered index. Now, what does this means? Clustered and non-clustered indexes. Okay, so the clustered index are you can have only one clustered index on the table. Okay, hold on to that. And then if it's a clustered index, it has to be on unique value column. It has to be a unique value column. You cannot have a clustered index on a column which is non-unique. Okay, the value should be unique. Usually the primary key becomes the clustered index. So when you create an index on the table, you always create on the primary key or the unique key of the column. Okay, that's a basic rule usually. It's all, but not in all cases. And then what I said, you can have only one clustered index on the table. Now the non-clustered index, it can be many. You can create as many indexes you want. Now why do I need many indexes on the table? Why do I need more than one index on the table? Can anyone tell me? Why do you need more than one index? Is one index enough for you when you're looking the data from the table? So let's say if I give you the book example again, you have the table of content with chapters. Okay, each section has few chapters in it. If I ask you, can you find out the section 5? What would you do? What would you do? If your table of content is by chapter, and inside the book there are sections, section 1, 2, 3. Each section contains few chapters. If I ask you, can you find me section 5? What would you do? That's a real world problem. Tell me, what would you do? I'm not asking you SQL. No? Okay. So all you do is you just go through one by one pages and until you find the section 5, right? So the same thing in the database is, in the database, if you are looking on the employee ID column, sometimes you look on the manager ID column, you look on the title, you look on birth date. So each of the data in the table column, you're looking at by different. You're not always looking by employee ID. So that's why only one index doesn't help, because sometimes you're looking by employee ID, other day you would be looking by manager ID, other day you would be looking the data by gender, by female, by birth date, by manager ID, by login ID, right? So that's why you need multiple indexes on the table. But let me ask you this. I told you need index on the multiple columns. So let's say I use the data to look up by each of the columns in the table. Okay, what I'm saying is you use to find the data in the table by any of these columns. You use all the columns to look up the data. Sometimes you use employee ID, sometimes you use national ID number, contact ID. You use each of these columns to find the data in the table. Would it be a good idea to create the indexes on all the columns? Yes or no? No. Perfect. No. If you create on everything, think about a book example. What you're doing is you're creating table of content in the book by chapter, by section, by paragraph, by line. Think about that. So you just creating the content. You're creating a table of content which is maybe the same as book. So if you have to find about section, you just have to go through a huge table of content, which takes time. So the more table of content, the more types of table of content you create, the more things you have to go through in order to find something in the book, right? So would you ever create a table of content by word, by each word in the book? You won't do that, right? You won't take the word and create a table of content, because if you create by word, or let's say if you create by section, paragraph, line, chapter, subchapter, there will be a huge table of content, and if you have to find something, you have to go through whole table of content first before you find anything in the book. That's another tedious task. So that's why you don't do, because if you create indexes on all of them, the SQL server has to go all of those indexes first. So the indexes would be a huge pile from which SQL server has to go in order to find the data. So that's why you don't create indexes on all the columns. You create indexes only on those columns that are frequently used. So that's why when you buy a book, the table of content doesn't come with everything. It just comes with chapter, because mostly you're going to look the book by chapter. You're not going to look by section. You're not going to look by subchapter. You're not going to look by paragraph, right? So that's why if someone gives you the book with all of these contents, table of content, which has table of content by chapter, by section, by paragraph, you will think, who was the person who published this book, right? You're not going to like it. So the same way, the SQL server doesn't like it if you put the table of content on each of the column. Okay, all right. So that's why you create table of content, or you create indexes only on those columns which you're going to use very frequent. Okay, you're going to use each column to search, but you make only on those columns which is you're going to use most. Okay, that's why, because if you just had a clustered index, you cannot create more than one on the table, right? But with the non-clustered index, so you can have one clustered index, and the remaining, if you need more than one, you create a non-clustered index on the table. Okay, clustered and non-clustered index. All right, now let me ask you this. Have you ever done sorting in Excel? Have you ever done sorting in Excel? Right? So when you sort the data by employee ID, can you sort the data by contact ID at the same time? Can you arrange the employee ID from 1 to 290 and the employee ID from increasing to decreasing order? Can both of them will be in this increasing to decreasing at the same time? You cannot have it, right? You can only sort the data on one column physically, right? You cannot sort on both, right? If you sort on contact ID, the employee ID would jumble up. If you try to sort the data by employee ID, it's going to jumble up the contact IDs, right? So that's why, because the clustered index is physically sort the data and store in the table. So when you create a clustered index on the table, what it's going to do? So it's going to store the data in the physical sorted by the column that you select as a primary or as a clustered index. So that's why you cannot have more than one key. Okay, so What I'm saying is you cannot have more than one clustered index because the SQL server stores the data physically sorted on the column that you say it's a clustered index. Okay, so if I say employee ID is a clustered index, then it will store the data in the table in sort by employee ID. Okay, but if you try to create a contact ID as a clustered index, what it's going to do, it has to resort the data and arrange contact ID from increasing to decreasing, right? Or decreasing to increasing, either way, right? And then it's going to mess up the employee ID, right? And the employee ID will jumble up. So that's why, because the clustered index, when it stores the data in the table, it physically sorts the data. That's why you can have only one clustered index on the table. Is that clear? So see, if I try to say order by contact ID, okay, so this is, I'm sorting it by contact ID. See, if I sort by contact ID, my employee ID got jumbled up, right? If I try to do by employee ID, my contact ID will jumble up. Right, so see, now here it starts with 1001, 1002, 3, 4, 5, 6. If I execute, it starts with 1290, 30, 1002, 1290, right? So now if the employee ID is arranged, the contact ID is jumbled. So because when you create a clustered index on a column, it physically sorts the data like this. Physically means everything is sorted. So that's why you can have only one clustered index on the table. Okay, and the non-clustered index doesn't follow the physical sorting. Okay, it doesn't physically sort the data, so that's why you can have many non-clustered indexes on the table. Okay, let me ask you this: if you understood the concept of the indexes, would it be a good idea to create a index on a column like gender where you have only two values, male and female? So let's say if I tell you there are 1 million rows in this table, all are with the value gender male and female, and you use this column very often, would you create an index on column like this? Would you create a column, an index on the gender column? If you use it you use it like every time, would it be a good idea to create an index on a column like gender? What do you think? Okay, let me give you an example. In your book, okay, you have only two chapter numbers, chapter 1 and chapter 2. Chapter 1 is half million times, and chapter 2 is also half million times. If I give you index with chapter number, and if I ask you, can you give me chapter 1, how many chapter 1 you're going to find in the book? Half million. Was that helpful? I mean, you still have half million rows to find if you're looking for something, right? Would that help much? No, because if you're looking for chapter 1, you still have half million which chapter 1 you're looking for, right? So let's say you had like chapter 1 and then other thing, with the name of the chapters are different. So still you have to go through half million records. The index, the table of content doesn't help you much, because you still have to find that particular chapter that you're looking for. You still have to find which one is you're looking for out of half million. So that table of content help you a lot? Not much, right? Because still left you with half of the records, that half of the chapters that you have to go through. So it helps, but not much. So there is no point if you still have to go through half million chapters. It's not a good index. Okay, so you try to avoid creating an indexes on such thing. That's why you don't have ever index by the word. You never create index by the word, because if the word is repeating, you don't want to create an index by the word, right? So what kind of thing when you create an index you look for? You look for which is the thing that is unique. The chapter number is unique in the book. So that's why you create a index or table of content on the thing that is unique, which is not repetitive. Because if it is repetitive, it's gonna appear many times and you don't know which one you're looking for. You know, you have to go through each of them. Oh, this is the one I was looking for, which is in middle or somewhere. So that's why if you have a column or the things that is repeated multiple times or it's keep repeating, you don't want to create index. It's not a good index because you're not gonna get much help with that. Make sense? Okay, perfect. So if you create a column index on gender, marital status, it's not gonna much help because the values are same. You still, even if you have the index created on this, when the index is done, it's gonna still left with half of the million rows or half of the data to search through, which is not good thing. Okay, so you always create an indexes on the column, those are unique, so you can quickly go through that record. You know, okay, I'm looking for employee 10, which is on this page. Done. Okay, all right. I mean, if there is some repetition, that's okay. You don't need much repetition. Okay, it's okay to have some repetitions, but not like almost half of the records are same. Not that kind of thing. Some is you're gonna have at least some repetitions anyways. You cannot get rid of everything except primary keys, right? Because primary key doesn't allow the same value. Okay, so now how do you do the indexes? How do you create the indexes? What do you do with the indexes? So we just talked about this thing. Now don't worry about how much space it takes on the pages. We're not going to go into the detail like what is the page in this. So this is more about the disk space. Like on the SQL server where it stores the data in the pages. Okay, in the disk, which is your hard drive, it's inside there are pages. Each page is 8 kilobytes. Okay, and each page is 8 kilobytes. So if you say 8 pages of 8 kilobytes is called an extent in the SQL server. Okay, so 8 pages, a group of 8 pages, it's called an extent. Okay, and the table is built of lots of extent. Okay, so in table you're gonna have lots of many pages, but each it's built with extent. Okay, so don't worry much about the architecture of the disk, how the SQL server do it. We're not gonna go into the detail. We talked about it. When you're gonna create a column primary key, it will be a unique column, and when you try to create an index, you're gonna create an index on a column which is unique as well, or very less repetitions. Even if it's not a unique, it should be very less repetitive. Okay, all right. So yeah, so we talked about would it be a good idea to create indexes on all the columns? We said no. So what is the other aspect other than I told you about the reading overhead? Because you're going to have a long list of content, right? If you create indexes on all the column, you're going to have a lot of if you create index on all the column, you're going to have long list of table of content. So in the book, you never ever tear the chapter apart or you add a chapter, right? When you read in the book, when you're reading, you never do that. But in the database, you always add the data, you always update the data, and you always delete the data. So think about, you're adding a chapter to the book, you're taking out the chapter to the book, or you're updating a chapter to the book. You're adding certain pages to the chapter. When you add a chapter to a book, what do you need to do? You need to change the table of content, right? When you take let's say there is a chapter 10 in between your book. If you take 2 pages out from chapter 10, what you need to do? You need to change whole content, right? Whole table of content, right? So that's why in the SQL server, that's another reason you don't want to create indexes on all column, because whenever you're updating or deleting the rows, you have to change table of content. So that's an overhead associated with each indexes, because you have to update that thing that from the index that this record is gone, this record is updated. this record is moved to the new pages. So that's why, because the data is fluid, it's keep moving, there is an overhead associated uh, with the data in the database. So that's why you try to avoid creating indexes on all the column. Okay, that's another reason. Okay, now when you are deleting the data, when you're adding the data, when you're updating the data, what can happen over the time? The data can get fragmented. Have you ever heard about your disk getting fragmented in your laptop? You might have heard of it. What happens? That some information is in one portion of the disk, the same information that you need for one thing is in the other. So your information is all over the places that you need for one thing. That makes the disk fragmented, and when you run your laptop, it runs slow. So the same thing, let's say if one of your table has some data in one place, some data from the same table in the other place, and some data in the other place, like totally separate. To read the data, it's become difficult. So in order to make the disk defragmented, it means all the data comes in one cluster and stick all together. You have things to do, is called as rebuild and reorganize indexes. Okay, so what do you do when you rebuild or reorganize is you defragment your disk. Okay, so that's what it's going to do. It's going to put all the things that are related to each other, will put together if they are separated on the disk in different portions. Okay, so when you build the indexes, because your data is inserted, updated, deleted, your data get fragmented on the disk. So in order to make the data defragmented, you use rebuild and reorganize of the indexes. Okay, what does it help? Can anyone think about it? What does it help? Why do you have to rebuild and reorganize the data? If you don't rebuild and reorganize your indexes, it will perform poor. The time will take higher, because the SQL server has to go in one portion, then another portion, then another portion. If everything would have been in one place, it would be quicker. So that's why, to make your query run better, you have to rebuild and reorganize indexes frequently. Okay, so it depends on how fast your data get fragmented. That fast you have to do rebuild and reorganize your indexes. Does it make sense? Okay, yes. So what I want you to do is, I want you to watch one lecture about indexes when you come to the next class. Okay, please watch that video. That's gonna help you a lot about indexes. We just talked very briefly about the topic. What I want to do is, I want you to see in very detail how the indexes work. There's a very nice video that I want you to watch. So I'm going to send you the link after the class. Watch that video and come in the next class. Okay, so we're not going to get into the much detail about the indexes. That's what we're going to talk about. And in the next class, I'm going to show you how to create the indexes, how to drop the indexes. Okay, so watch that video and come. That video is just going to talk about the concepts of the indexes that we talked today as well. Okay, any questions?